Hi dear students, welcome to my channel. This video is useful for 8th standard onwards. Keep watching. Okay students, you see here. In this video what we discuss is free body diagram for this system. One glass is there, two lemons. You assume they are spherical. Okay, I am dropping here. It is touching the bottom of the glass. So one more also I am dropping. This is not touching the bottom of the glass, but it is lying on the bottommost lemon. Okay, the bottommost lemon touching this surface, topmost lemon touching this surface. Okay, then what is the free body diagram for the bottommost lemon, and what is the free body diagram for the topmost lemon? Okay, the basic thing, what are the forces acting on each mass? First you have to write, and because of that mass, because of that weight, what are the reaction forces coming on that particular mass? That we are going to draw, that we are going to understand in this video. Okay, keep watching forward, you will understand. See here, glass is there. I am dropping one spherical lemon. So on this lemon, the downward force is gravity, but it is not falling down because the bottommost portion of the glass exerting force upward, that is normal force. Okay, suppose this is touching this surface, but still this surface not exerting force on this lemon because there is no force along this direction. That is why there is no reaction along this direction. Now only one force, downward gravity, upward normal force due to the bottom of the glass. Okay, now I am dropping one more spherical lemon. This lemon is not falling down because it is sitting on this lemon. Now you see what are the forces acting on the second lemon. On the second lemon, the downward force is gravity, gravitational force, that is weight. Another one, this lemon is not falling down, no, because this is balanced by this one. This lemon exerting one force along this direction. Okay, so because of this also exerting force on the bottom lemon along this direction. So it has two components, one is like this, one is downward. Because of this along this direction, so this surface exerts a force on this lemon along this direction. Okay, you watch forward, free body diagrams for this lemon and this lemon, you will understand very clearly. Okay, this is class number 44. See the free body diagram for the two masses M1 and M2. This is lemon 1 and lemon 2. See here, this is mass M1, lemon 1. The force acting on this lemon downward due to gravitational force, that is weight, M1G. M1 is given, G is acceleration due to gravity is given. Okay. Now, this force is balanced by reaction force upward, that is N1, normal force exerted by bottom of the glass, this one. So downward M1G, upward is N1. Okay, now you see another lemon. of mass M2. It is lying like this. On this M2, downward force is M2G, gravitational force, that is weight. But this lemon is not touching the bottom. It is touching another lemon at this point. So, this lemon exerts force along this direction. I am calling it R1. Okay? At the same time, this M2 also exerts force on M1 along this direction. So definitely, if this is R1, it must be R1. Because action is equal to minus reaction, no? So M2 exerting force on M1 along this direction, that is R1. This M1 exerting force on M2 along this direction, that is R1. Okay? Now we'll come back to here. So this exerting force on M1, that is R1 along this direction. Because of this force, it has two components. One is along this direction, one is downward. So because of force along this direction, so one normal force acts on this M1 along this direction, that is N2. Okay? Because of this N2, here this surface also exerts a force on M2 along this direction. This is N3. You're understanding? Globally means together, if you take this whole as a system, this M1 and M2 as a system, upward forces is equal to downward force. If I consider M1, M2 together a system, upward force is N1 must be equal to downward forces are M1G plus M2G. The beauty is we can prove it. Okay? For that, first what we will do, we will write the free body diagram for each mass. For M1 we will write the equations. For M2 we will draw the free body diagram and write the equations, and we'll find out this normal forces. The one more important thing what you have to see is, this is downward direction, no? This is radius of M2, this is radius of M1. I am joining this line. This line makes an angle theta with this line. This is given, theta is given, M1 is given, M2 is given, G is given. What we have to calculate? N2 we have to calculate, N1 we have to calculate, R1 we have to calculate. And N3, N1, N2, N3 and R1. Total 4 variables are there. We have to calculate these 4 variables by using the equations we will obtain from the free body diagram. Okay? On M1, the forces downward gravitational force M1G, upward reaction force N1. Along this direction, this reaction force by M2 mass, along this direction I am calling R1. It makes an angle theta with this direction. This is N2, the normal reaction force on the mass M1 due to the surface of the glass. Side surface is there, no, like this, along this direction, N2. Okay? Now we will resolve the components for R1. This is some right angle triangle. This is hypotenuse. This is adjacent side. This is opposite side. So it has two components. Along this direction, R1 sin theta. Along this direction, R1 cos theta. That only. This is R1 sin theta. Downward R1 cos theta. M1G already there. M1G. Along this direction N2. Upward direction N1. We will write the equations. Upward force is equal to downward forces. N1 equal to R1 cos theta plus M1G. This is equation 1. Now, right side force is equal to left side force. N2 equal to R1 sin theta. This is equation 2. Free body diagram for M2. Downward M2G, that is due to weight. Left side N3. This is normal reaction force exerted by this surface. Along this direction R1, that is the reaction force exerted by mass M1 on M2 along this direction. Okay? So this makes angle theta with this direction. So it has two components. This is right angle triangle. This is hypotenuse. So R1 has two components. Along this direction R1 cos theta. Along this direction R1 sin theta. Now we will write the equations for this free body diagram. Okay? See here, on mass M2, downward is weight M2G. Upward is R1 cos theta. Left side N3. That is a normal reaction force on the M2 due to the surface of the glass. Along this direction R1 sin theta. Okay, these two are components of R1. Now we will write the equations. Left side force N3 equal to right side force R1 sin theta. N3 equal to R1 sin theta. This is equation 3. Okay. Now upward force R1 cos theta equal to downward force M2G. R1 cos theta is equal to M2G. This is equation 4. Okay. See here, 4 variables N1, N2, N3 and R1 and 4 equations. 4 variables, 4 equations. Finite solutions. Means we can solve the equations to find out N1, N2, N3 and R1. Okay? From equations 3 and 4, I am dividing. This is R1 sin theta divided by R1 cos theta. This divided by this equal to this divided by, that is N3 by M2G. Means R1 sin theta divided by R1 cos theta is equal to N3 divided by M2G. So R1 cancel. Sin theta by cos theta equal to tan theta. Tan theta is equal to N3 divided by M2G. So N3 equal to M2G into tan theta. You know M2, G and theta. So we can calculate N3. Okay. From equations 2 and 3, N2 equal to N3 equal to M2G tan theta. Okay. From equation 4, directly we can write R1 equal to M2G divided by cos theta. This equation is valid for theta must be less than 90 degrees. Okay. From equation 1, N1 equal to R1 cos theta plus M1G. R1 I am substituting this here. N1 equal to M2G divided by cos theta into cos theta plus M1G. Cos theta cancels. N1 equal to M2G plus M1G. Initially I told no. This we have proved ultimately. This is the beauty of mathematics. Okay? I hope you understand. The most important thing is you have to practice a lot. Minimum 2 to 3 times you practice. You will understand very clearly. Okay? Please like this video, share this video and subscribe my channel and tap the bell icon to get the notification for further uploads of my videos. Till next video, bye bye, tata.